5.5 part 2 is roots of real numbers. So we kind of had a little preview of square roots, cube roots, and so on last time. So now we're going to do square roots, cube roots, and so on with variables as well. So with x's, y's, z's. All right, so it says we know that squaring something and taking the square root of something, they're inverses of each other. Okay, kind of like multiplication and division undo each other. So similarly, there are roots that are inverses of larger powers as well. So if I have 5 and negative 5, 5 and negative 5 are the square roots of 25 because 5 squared is equal to 25 and negative 5 squared is equal to 25 as well. And then 2 is the cube root of 8 because 2 cubed is equal to 8. What about negative 2 cubed? What is negative 2 cubed? Negative 8, right? So that one is not. It's only the positive version of that. And then 2 and negative 2. So back to a positive and negative. These are the fourth roots of 16 because 2 to the fourth is equal to 16. And negative 2 to the fourth is equal to 16. Okay, and then it says a is the nth root of b if there's two things. So the nth root of b is equal to a, but also you could have b is equal to a to the n. N is any kind of root. It can be square root, cube root, whatever. So it says the nth root of a real number can be written as the radical expression nth root of a or nth root of b, where n is the index and a is what's called the radicand. Okay, so the inside of the square root, we call that the radicand. I'm never going to call it the radicand. I'm always going to say the inside of the square root because I think it's kind of strange to call it a radicand. Whatever, you can call it the correct terms if you want. All right, it says when a number has more than one real root, the radical sign indicates only the positive root or the principal root. Okay, so this is very confusing for students. So we're going to talk about some confusing things in this section. This is why we had a little preview of this section. So it says if we see the square root of 16, the square root of 16 is 4. Okay, but I just told you that the square root of 16 was really plus or minus 4, so that's kind of confusing. Okay, so if I see just the square root of 16, it is positive 4. Even though there are actually two numbers that can be squared to get 16. 4 is what we call the principal root. Okay, but if we have an equation like x squared equals 16, if I'm trying to solve that equation, I take the square root of both sides, square root, and whenever you take the square root, you always put signs. So you put plus or minus. So you get x equals plus or minus 4, okay? So we could have various equations. We could have like the square root of 9 plus x minus the square root of 16 equals 3x. And these numbers right here already have signs with them. Okay, so this would be like saying 3 plus x minus 4 equals 3x. I don't put pluses or minuses for each thing because in the problem already, it was like I had an imaginary sign in front of it. Do you guys understand that? It's like there was already a little plus there. Okay, so that's called the principal root. Okay, so numbers and types of real roots. So let's say that you take an odd root. So you're solving an equation, you take an odd root. How many answers would you have? Would I do a plus or minus? Yeah, it would just be one answer, right? I would not do a plus or minus. So there's one answer. So if I had like x cubed equals 8, that means that x is equal to the cube root of 8, which is 2, right? There's one answer. Not plus or minus 2. But if it says you have an even root and a positive radicand, so what if I have x squared equals 36? When I take the square root, I do the plus or minus. So Cole's saying there are two answers. Do you guys agree? X equals plus or minus 6, exactly. But what if there was an even root and there was a negative radicand, a negative number under the root? So if I had x squared equals negative 4. Yeah, there's no real answers, right? You can't take the square root of a negative number. You can't say some number times itself gives you negative 4. It doesn't work, right? So the number of answers or number of real answers is 0. So that would be no solution. We are going to talk about imaginary solutions eventually, but right now, no solution. And then the radicand of 0, if I have a positive or negative, if I had like x squared equals 0, or if I had x cubed equals 0, how many answers are there? There's just one answer, and what is that answer? 0. Exactly, so kind of keep that in mind. So if you have an even root, you're going to have plus or minus. All right, so find all real roots. So the fifth roots of 32. So if I was solving an equation and I said x to the fifth is equal to 32, what would my answer be? Do you guys know what it is? 2. Yeah, it's 2. Sorry, I thought you said 5. I was like, no. All right, the cube roots of negative 125. So if you're solving an equation where you have x cubed equals negative 125, what's x? So what times itself? Negative 5. What times itself 3 times gives you 125. Right, and you can do a little factor too if you need to, like we did in the last section. The eighth roots of negative 256. So if I have x to the eighth equals a negative number, can that happen? No, so this is a no solution. Do you guys see that? You can't have a number multiplied by itself, so you have a total of 8 of them, equaling a negative number. We can do b because it's a cube root, right? So if you have a negative 3 times, it's okay. But if you have a negative 8 times, it would end up being positive. All right, so we're kind of working towards where we're going to have variables. Okay, so it says simplify. So what if I have plus or minus the square root of 16x to the 6th? So the square root of 16 is 4. What about the square root of x to the 6th? What do you think? What times itself makes x to the 6th? X to the 3rd. So we have plus or minus 4x to the 3rd. Okay, this one has a negative out front. Negatives out front are fine, so we just have a negative out front. So what do you guys think if I have the square root of something to the 4th power? Well, what if I had the square root of x to the 4th? What would that be? X squared. So what do you think this one's going to be? It's going to be q cubed plus 5 squared, like that. And you could FOIL it out. You would get something that starts out with q to the 6th. Is that what you're saying? Yeah, you could do that. But you would actually have to FOIL it, right? You wouldn't just be able to bring that squared in. Remember the freshman dream I was talking about? You can't just bring that in and say, oh, it's q to the 6th plus 25. You can't do that. You'd have to FOIL it. I would just leave it like that. So you would need to FOIL if trying to simplify. Just like if I had x to the 4th under a square root. Right, if I had x to the 4th under a square root, it ends up being x squared, like that. Same idea. Okay, a little bit harder. So the 5th root of 24, a to the 10th, b to the 15th. So the 5th root of 24, you can try the little factor tree. You have 3 and 8, and then 8 breaks down to 2, 2, and 2. But notice how there's no sets of 5 items. That's what we talked about last time. No sets of 5. So I can't like simplify down the 5th root of 24. So that's staying how it is. It's still the 5th root of 24. But what about the a to the 10th, b to the 15th? So the a to the 10th under a 5th root. So Becca's saying a squared. Do you guys agree? Yeah. How about the b to the 15th under a 5th root? Yeah, b cubed. So what's the pattern? What are we doing each time with those numbers? Yeah, it's like 5 times what gives you 10. In other words, 10 divided by whatever your root was. Does that make sense? If you had a to the 10th, you're saying, oh, a to the 10th divided by 5. A to the 10 divided by 5 is a to the 2, right? All right, so this next one, yeah, no real solution. That will end up being what we call an imaginary solution. So no real number. All right, let's try the next one. So it says, now on to the most confusing part. Don't you love when your math teacher says that? On to the most confusing part of the chapter. Pay attention. All right, so it says, what is the square root of negative 5 squared? It is not negative 5. It's 5, because if you start with the square root of negative 5 squared, you do the inside part first. Negative 5 squared is 25. And we know the square root of 25 is the principal root, the positive version. It's like there's an imaginary sign out front and it's already plus, so it equals 5. But what if I had the square root of 7 squared? That's the square root of 49, which is 7. So it's like, wait a second. The negative 5 squared under square root, the square root and square didn't cancel, but why did 7 cancel? Yeah.
Why wouldn't it be positive 5 and negative 5?
It is not positive and negative, so you missed that part because you were left for a little bit, Eric. So it's not a plus or minus out front. There is an imaginary sign that's a plus. Okay? So that's called the principal root. It's only the positive version. All right, so here we go. So I have the square root of 7 squared is 49. Square root of 49, which is 7. So what do we think the square root of x squared is? Is it x? Does the square root and square cancel? You would think so. Well, kind of. But what about the 7? That ended up just being itself. It's the positive version of x. How do we do the positive version of x? It's the positive version of x, which is the absolute value of x. Ah, tricky, tricky. So if x was negative, it ends up being, so if you had like the square root of negative 6 squared, that ends up being 6. But if I had the square root of 9 squared, it ends up being itself 9, right?
But isn't it positive? Is that under sign? Is it implied that it's positive? Why do we have to put the absolute value?
Because x on the inside could be a negative number, like this. Like you could have negative 6 squared, that becomes 36.
Yeah.
And then under square root, it becomes 6. So if this was a negative 6, if x was a negative 6, we don't want to just not have these things there because it's not just x. It's not just 6, right? X is an unknown. We don't know what it is. What if it was negative? Then that indicates that it could be negative. So we do absolute values to indicate, oh, wait, we're going to take the positive version of that number. I'll get the light bulb moment in a little bit. We'll try some examples, see if it comes to you. All right, so here's the key. So it says if you're trying to find the nth root of an even power, and the result is the number raised to an odd power, like 1 or x cubed or x to the 5th, you have to write the absolute value to ensure that it's not negative. All right. It says you only need absolute values around variables. It wouldn't make sense to write the absolute value of 5 instead of just 5, right? Okay, so let's start out with this one. So I have the 8th root of x to the 8th. So what I always tell students every year is to go with your gut and write what you think it is without any absolute values to begin with. Okay, so without any absolute values, it's like, oh, the 8th root of x to the 8th would be x to the what power? First, right? X to the first. 8th root of x to the 8th. Now let's think about it. If I had a negative number in there and I raised it to the positive 8th and then take the 8th root of it, a negative number to the 8th power, will that be positive or negative? Positive. Now when you take the 8th root, you get a positive out, okay? So we want our final outcome to be positive. We don't know what x was. X is unknown. X could have been negative 2. So when I simplified all this out, I'm going to get positive 2 out. So that's why I need an absolute value around that, because x could be positive or negative. We don't know what x is. X is an unknown value. So to indicate that we get the positive version out, always we put absolute values. So this next one, the 4th root of 81. The 4th root of 81, what is that? It's 3, right? Because it breaks into 9 and 9. And then 9 and 9 break into 3 times 3 times 3 times 3. Do your factor tree, right? So we have a 3 from that. What about the 4th root of a plus 1 to the 12th? A plus 1 to what power? 3. All right. So we had an even root again. Depending on what a is, let's say a was negative 5. Negative 5 plus 1 raised to the 3, is that positive or negative? It would be negative, right? We don't want negatives out. We always want positives if we're taking an even root. So this could be negative. So because of that, we put absolute values around it. So we do 3 and then absolute value of a plus 1 cubed. Not always. So we'll talk about why we won't. So how about this next one? So I have t to the, what do you think? 3rd. Did I start out with an even root? Yes. Did I end up with something that was an odd power at the end? Yes. That's when I need an absolute value. So if you want to do a little checklist, you can. So even root, check. Odd power end, check. That means we need absolute values. So therefore, absolute values. So how about the next one? 2a minus 1 to the second. Do I have an even root to begin with? Yes. Did I end up with an odd power? No. Why do I not need absolute values around this? Either way, yeah. Either way, it's going to be positive. Do you guys understand what he's saying? It doesn't matter if A is, like, A could be anything. What if A was negative 18 billion? When you plug in negative 18 billion times 2 minus 1, but then you square it, it doesn't matter how big it was as a negative number. When you take a negative number and you square it, you get a positive number anyway. So this is positive anyway. So we don't need absolute values, right? Because it was all squared. Anything squared is always going to be positive, right? If I had negative 5 and I squared it, it's 25. All right, so this next one, so the fourth root of a to the 8th, b to the 12th, c to the 16th. So let's just use our intuition. So it'd be, oh, it's a to the 2nd, b to the 3rd, c to the 4th, right? We're just dividing those powers. 8 divided by 4, 12 divided by 4, 16 divided by 4. Depending on if a, b, or c were positive or negative, could any of those parts be positive or negative? So a squared is automatically positive. C to the 4th, automatically positive. What about b cubed? It could be positive or negative. So did we have an even root originally? Did we end up with an odd power for one of them? Yeah, so we're going to put absolute values around just that part. You guys getting it?
So why don't we just put it around the whole thing, just to make sure everyone knows what's going on?
Yeah, I guess. I don't know. I don't know why we just put it around that.
Honestly, it says it wouldn't make sense to put absolute values around the 5 instead of just 5, but why would it make sense?
Because like the absolute value of 5 is just 5, right? So we don't need absolute values around it. So to indicate that you know the correct way of doing this, put it around only the part that needs it. All right, so how about this? So cube root of 27, that's going to be 3. X minus 5 to the 9th under a cube root is going to be x minus 5 to the 3. Do I need absolute values? No. Right? No absolute values. Why?
Because there is no even root.
Yeah, because it was an odd root. So odd roots, is it okay if I take the cube root of negative 8? Does that work? Yeah, cube root of negative 8 is going to be negative 2. It's okay that it's odd, that it's negative in the end. You can have negatives with odd roots. So that one's good. All right, how about the next one? So fourth root of x to the 8th is going to be x squared. Y to the 16th under a fourth root is going to be y to the 4th. How about the next one? The fourth root of z to the 10th. How many sets of 4 would you have if you wrote out z times z times z, like 10 times total? You'd have 2 sets of 4. So z squared on the outside. How many are left over? 2. So we leave a fourth root of z squared. So do you? I don't know. Do we need any absolute values?
No.
Why? They're all even. Does that make sense? X squared, y to the 4th, z to the 2nd, those are all positive anyway, so we don't need absolute values around them. Doesn't matter what x, y, and z were, whenever you square or raise it to the 4th or square, you're going to get a positive number. So you don't need it.
I'm confused. So you said like we put an absolute value when it's an odd number?
If it's an even root first, and you end up with something with an odd power. Not an odd number, but an odd power. All right, so this one. So if I have the square root of 8, how does the square root of 8 simplify? Well, just like we did yesterday, it would be, you can break into the factor tree 4 and 2, 2, 2, and 2. So we have a set of 2 items that are the same. So we're going to have a 2 on the outside, and a 2's left on the inside. So how about the x, y's, and z's? So if I had 5 x's, how many pairs would I have? 2. How many would be left over? 1. How about the y's? How many pairs of do I have when I have 6 y's? 3. And the z's? 5. So I had an even root originally because I had a square root. It's a 2 in there. Did I end up with anything raised to an odd power? I did. So depending on what y and z are, those could be negative, right? If I had like -2 for y or -1 for z, that would be a negative output. So we put absolute values around just that part. All right, so we're going to practice solving equations as well. So if I have 2x squared minus 10 equals 40, I would add 10 to both sides. I would divide by 2. I get x squared equals 25. I now take the square root. When I take a square root, remember, when I take a square root, I always write plus or minus. So if the square root was originally in the problem, it's automatically plus. Like the sign in front of it is plus. But if I take a square root, I write plus or minus. So I get x equals plus or minus 5. Does that make sense? 5 and -5, when squared, give you 25. So we took the square root, so don't forget plus or minus. All right, so the next one. So I'm going to combine my like terms. 2y cubed plus 5y cubed is 7y cubed. Minus 7 equals 182. Add the 7 is going to be 189. Y cubed is equal to 189 divided by 7. Is that 27? Is that right? You guys do that for me. I think it is. 27 times 7. Yeah, 189. All right, so then what is y? Yeah, I take the cube root. I take the cube root. Why do I not do a plus or minus?
It's odd.
It's an odd root, right? It's already positive, so it's going to be y equals 3. There's not two things that multiplied by itself 3 times to make 27. It's only 3 times 3 times 3 that makes 27, not -3 times -3 times -3. Yeah, cool.
So you should be able to tell before you solve the problem that it's going to be negative, positive, or...
Right, if there's going to be 2 answers or 1 answer. Yeah, pretty much. Do you guys see what he's saying? So like the first one I knew there were going to be 2 answers, or it could have been no solution, right? But then the second one I knew that there was going to be 1 solution. So this one, same idea. Let's subtract our 10x the 4th over. So we get 5x the 4th equals 80. I divide by 5. So I get x the 4th equals 16. I take the square root, or not the square root, the 4th root, right? Do you think a 4th root needs a plus or minus? Yeah. Plus or minus. So I get x equals plus or minus 4th root of 16? 2. Same thing over here, so I get -2z to the 6th when I combine. If I add the 2 to both sides, I get -1458. Divide by 2. Positive 729. Anybody know what times itself 6 times gives 729? Probably not. It is 3. So 729, if you break it into its factors, you can see 3 goes into it because, yeah, you were right. Did you not think you were going to be right? So if you add up the digits 7 plus 2 plus 9, you get 18. Is 18 divisible by 3? Yeah. Is 18 divisible by 9? Yeah, so let's go even bigger. So let's do 9. 9 goes in if you do your 729 divided by 9. Can you guys do it in your head? 8 because of the 72. 81, exactly. So 81. 81 breaks into 9 and 9. So we get 3 times 3 times 3 times 3 times 3 times 3. It's usually something very, very small. Like some people are like, oh, I think it's going to be like 27. 27 times itself 6 times is a very big number, right? It's usually a very, very small number. So z equals, if I take the 6th root, what do we think? Yeah, you need the plus or minus. So it's going to be plus or minus, not 6, 3. All right, does that make sense? You guys get it? All right. So how about if I have something like this? This is something that still like trips my AP Calc students up. Like they've been doing this since Algebra 2. I don't know why they still like mess these up. Okay, this involves something we call the zero product property. Okay, so this is not one where I can like take the square root of x squared. Do you guys see what I'm saying? Like you have an x squared and you have an x. I can't like get only an x squared on one side without having an x on the other side. You see that? So on these ones, we subtract our 6 over, and we factor So if you have an x squared and x, that's set equal to 0. You have to set it equal to 0 if you have an x squared and x. So you have to get everything on one side. And then we factor. So if I'm factoring an x squared minus 5x minus 6, it factors into an x and x, a 6 and a 1. My outer and inner need to combine to be -5, so I need a negative with the 6 and a positive with the 1. So see how the outer and inner combine to be -5x. All right, so what we're saying is that we have some number times another number, and we equal 0. Well, if that's true, if I have a number times another number equaling 0, it has to be, one of those has to be 0, right? Yeah, so we set each one equal to 0. So we say x plus 1 equals 0, and we say x minus 6 equals 0. And we set each one equal to 0 and solve. So I get x equals -1 and x equals 6. Does this kind of bring back Algebra 1 memories to you? Have you done this in Algebra 1?
Yeah.
All right, both of those are your answers. So if you went all the way back to the original and you plugged in 6, you'd have 6 squared is 36 minus 30 gives you 6. It works out, right? -1. -1 squared is 1 plus 5. 1 plus 5 is 6. Both of them work in the original. So same thing with this one. If I subtract my 3 over and then I factor, this is a hard one to factor. It's one of my favorite ones to put on a test because I don't have to worry about the signs. I know it will always factor. Like when I'm creating the problem, I don't have to worry if it's plus or minus or whatever. All right, so I know I need a 3 and a 1, but where that 3 and 1 go is a mystery, right? We need them to be opposite signs to make a -3. So I actually put the 3 on the outside with the 2, like for my outer swoop, and the 1 on the inside. So I'm going to get 6 and 1. I need a -6 and a +1. So combined to be -5. So some of you guys might have tried the 2x and x, and you might have said, oh, I'm going to need a 3 here and a 1 here so that I combine and I can get -5 if I get negative and negative. That also makes -5. Do you guys see it? But what is wrong with that way? Yeah, if you multiply the last terms, you get +3. Okay, so be careful. All right, so set each one equal to 0. Oops. So if I have 2x plus 1 equals 0, and I have x minus 3 equals 0, I get x equals 3, that's the first one. I subtract my 1 over and divide by 2, and I get -1/2, that's the other one. And you can check all the way back in the original, both of those will work. Okay, so the next part says, well, what about equations that already have square roots in them? So if I have the square root of 9, remember I said that was 3. The square root of 16 is 4. This is almost exactly the same example I had earlier. Minus x equals 3x. So we'd get 7 minus x equals 3x. Add the x over, so I get 4x equals 7. So 7/4 is equal to x. Okay, so if there's already a square root in there, it's the principal root. There's an invisible sign. It's a plus in front of it. Okay, it doesn't have plus or minus. All right, is this all making sense? You guys feel pretty good about these? All right, and then sometimes you have like some real life problems. And when you have real life problems, sometimes it's really awkward to be like, oh, you're just going to measure this piece of wood. That's going to be like 7 square root of 2 feet. Like, we don't say, like, measure it to 7 square root of 2 feet, right? It's kind of strange. So we would use a calculator to help us on these, and we would round to whatever it says, nearest tenth, nearest hundredth. If it doesn't say, I always do 3 decimals because it's an AP Calc thing. You always do 3 decimals in AP Calc. So if it doesn't say, do 3 decimals. So it says the time t in seconds that it takes a pendulum to make a complete swing back and forth is given by the formula t equals 2 pi times the square root of L over g. So L is the length of the pendulum in feet, and g is the acceleration due to gravity, which is 32 feet per second squared. So find the value of t for a 1.75 foot long pendulum. Okay, so this is a real life equation. So t is going to be 2 pi. You have the square root of the length, and our length was 1.75 feet, divided by gravity, which is 32. So in your calculator, you're probably going to have to put like parentheses around the inside part, okay? So mine will show up like as a square root, and it will have a parenthesis. I would need to do 1.75 divided by 32, and then a parenthesis. So check on your calculator, make sure you get the same thing, that you're putting it in right. we'll round to 3 decimal places since I didn't say. There is a pi button. Use the pi button. Do not use 3.14. The pi button is underneath clear, so do second and then the little, it's called a caret. It's like this little symbol, the little up symbol. It's on the right-hand side. So when I put this in, I got 1.469. Did you guys get that? And this is a time. It says the time t in seconds, so we're going to write seconds next to it. Right. And then the same thing for the last one. So it says the relationship between the length and mass of a Pacific halibut can be approximated by the equation L equals 0.46 cube root of m. Do you see how big this fish is? Isn't that crazy? I'm not a fisherman. Did I say it right? I don't even know how to say the word. All right, where L is the length in meters and m is the mass in kilograms. Okay, so it says use this to find the length of a 25 kilograms. So that's going to be our mass. So we're going to have L equals 0.46, and then we have the cube root of 25. So the cube root of 25. There is a button. Let me pull up my calculator. There is a button on your calculator that does cube root, but I'll show you another way to do it too. So on your calculator, if you go to math, do you guys see the button math on the left-hand side? And you hit math, and you go down, you see how that says cube root. It's option number 4 on mine. So cube root of something. You can put in the cube root of 25, find the answer, and then multiply by your 0.46. So that's the first way that you can put it in. So 1.345, which is in meters. So it's pretty big. All right, but if you didn't want to do that, you can also do 25 and then raise to. So that little caret symbol I was talking about, raise to, and then do parentheses 1/3. A 1/3 power is the same as a cube root. Do you guys see how the cube root of 25 is the same as 25 to the 1/3? So 2.9424, and then multiply by the 0.46. So either way, you should get 1.345 meters. All right, so let me pass out your homework. That was the last one, right? I have more. All right, one more. I'll skip it, but same idea. Plug the numbers in, see if you can get it while I pass out paper.